All right, so they just get increasingly more difficult. And because we have both x squared and x, y squared and y, we're going to complete the square for both of those. First thing I'm going to do, though, is get rid of the 41. I'm just going to collect numbers over on that right-hand side. So on both the x squared and the y squared, I'm going to factor out a number factor. And it always works out pretty nice this way. 9 goes into 54, 6x times. Okay, so I'm going to complete the square using the 6x and also the negative 2y. So b over 2 squared, that's going to 6 over 2 squared gives me 3 squared, which gives me 9. And I'm going to do the same with the negative 2. Okay, so I need to add the 9 to the inside of this parentheses. So on the right-hand side, I'm going to add 9 times 9, because remember, there's a 9 multiplying my parentheses on the outside. Same idea with the y's. I'm going to add 4 inside the parentheses, so I'm going to add negative 4 times 1 outside the parentheses. Okay, that allows me to rewrite so I have perfect square trinomials inside my 2 parentheses, which is what I want, because remember, I want x plus or minus some number squared, and the same with y. And negative 41, 9 times 9 is 81, and then subtract 4. On the right-hand side, that gives me a 30. That gives me a negative 41 plus 81, that's a positive 40, minus 4, that looks like a 36. All right, now let's finish up what I'm doing here. So I get 9 times x plus 3 squared minus 4 times y minus 1 squared equal 36. Now, if you're not sure what to write in the binomial, and this is why I show this step, you just go back to it right before you're squaring it, and that's the number that always shows up in the binomial. All right, now remember, I need some fractions here, so I'm going to start just by dividing everything, the whole equation, by 9. So I get x plus 3 squared minus 4/9, y minus 1 squared equals 36 divided by 9 is 4. Okay, I'm going to leave the 9 in the denominator over the y minus 1. I'm going to get rid of the 4 by dividing everything by 4. And you know you're on the right track when you get a 1 on the right-hand side. So this simplifies to x plus 3 squared all over 4 minus y minus 1 squared all over 9 equals 1. So what do I get out of this? Well, let's identify a and b and also h and k. So h and k are my transformations left and right. H is the left-right transformation, so I'm going to change the sign on the plus 3. K is my up-down, and I still have to change the sign because I'm moving it out of the parentheses. And looks like a is equal to 2 because 4 is 2 squared, and b is equal to 3 because 9 is 3 squared. That allows me to answer the rest of the questions. Okay, where are my vertices? Okay, my vertices are found, and again, I'm using the guide on page 767 in order to write these little equations. My vertices are going to be at h minus a, comma k, and also h plus a, comma k. So we're taking the a and the left, right, and up, down transformations, putting them together to figure out where our vertices are. So h is -3. So -3 minus a, which is 2. -3 minus 2 is -5. And k was 1. And h plus a, so -3 plus 2 is going to be -1, and k is still 1. All right, my foci are found at h minus c, k, and h plus c, k. And this is for the hyperbolas that will cross the x-axis. It's different. There's different little formulas if they're crossing the y-axis. So use the guide on page 767. All right, I have to calculate c. C is a squared plus b squared. C squared is a squared plus b squared. So 2 squared plus 3 squared, that's 4 plus 9. So c squared is 13. C is going to be the square root of 13. All right, so h minus c. H is, again, -3. -3 minus the square root of 13. And k again is still at 1. And h plus c is -3 plus square root of 13. And again at 1. The asymptotes are going to be at y equals plus minus. They write them out separately. I don't know why. B over a x minus h plus k. So y equals b over a, 3 over 2, x minus a -3, which is x plus 3, plus k, which is 1, and y equals -3 halves, x plus 3 plus 1. And since we just have to enter those, we don't have to simplify them. I would enter them just like they are. And we're done with that problem and done with this video.